Hello friends, welcome to the fourth lesson of Arduino training series, and in this lesson we're going to see how to add and switch to an Arduino project. In the previous lesson we have learned how to add an LED as an output device to an Arduino project. So let's understand what is a switch, how it works, and how we can able to connect to an Arduino project, and so that we can able to control an LED and other devices connected to Arduino Uno. In general, when you look at a tag switch, then every tag switch has a 4 legs, let's say 1 and 2 and 3 and 4. These are the 4 pins to every switch. So even though it has a 4 legs, 1 and 3 is internally connected. So pin number 1 and 3 is internally connected. That means they are short. And 2 and 4 are internally connected short. So this means even if there are 4 legs, there are only 2 pins, let's say 1 and 2, that make a sense here, right? If you think like how it's been represented, how the switch has been represented into the electronic circuit, then you can able to see in the lower right corner there is an image which represents the symbolic form of the switch. You might have seen a lot of schematics and electronic circuit with this kind of a symbol of a switch. Switch is very interesting and fascinating components in electronics because it's been used to give an input to an electronic circuit. Let's say if you press the switch, then something to be happen, and if you press the switch again, if you release the switch, then something else needs to be happen. So this is one case where you will often use the switch in your project. The second place is to generate an interrupt. In embedded system, if you want to generate an external interrupt, then adding a switch to generate that interrupt is a very famous practice. I mean, it's very popular way of generating interrupts because switch are very handy to add, and when you press the switch, then certain piece of code will run and certain function has to be performed. So after understanding the switch, and also I want to tell you that like you might have seen a lot of products that around you which uses this kind of tag switch. Say for example a microwave oven, or you might have seen the older television or the copy machines which uses this kind of switch. So you may be using it already. So if you ask me how we're going to add the switch to an Arduino, then we will be using only 2 pins out of this 4 pins of the switch. We will going to use pin number 1 and pin number 2 of the switch, and we're going to keep it open 3 and 4. We're not going to connect anything to the switch. Pin number 3 and 4 of the switch, so we're going to use only 1 and 2 pin. Okay, so when it comes to setting up the circuit for the project, then you can see I have one LED connected to an Arduino Uno and I have one switch. So in this project, what we're going to do is when we press the switch, then LED will turn on. When we press the switch again, then LED will turn off. So there are so many things you can see on the circuit. Let me explain to you. The LED that you have, the red LED, that will going to connect to pin number 13. So you can see the longer leg of the LED will going to connect to the pin number 13. If you follow my mouse cursor, then you can see the longer leg of the LED will going to connect to pin number 13 via this 1 kilo ohm current limiting resistor, right? And the shorter leg of the LED will going to connect to the ground. The connection of LED will remains the same from the previous lesson. Now let's understand how we're going to connect the switch, right? If you look at the switch carefully, you might have realized that I have used only 2 pins, pin number 1 and pin number 2. So one end of the switch, I mean the pin number 1, will going to connect to pin number 8 of the Arduino, because the pin number 8 that we will be using as an input pin, right? So that should connect to the one end of the switch. The other pin of the switch will going to connect to the 5 volt of the Arduino Uno, right? You can follow my mouse cursor. The one thing may bothers you is why I have used this 1 kilo ohm resistor. The way we will going to connect the switch to an Arduino is by using external pull down resistor. Now you might get another question that why this external pull down resistor we will be using. So the reason is whenever you configure any pin on Arduino as an input pin, then that pin will be kept as a floating, right? So the float pins is the one that doesn't have either 0 or 1. It's neither a logic low or logic high, right? So it doesn't have the states by default. So it's a good practice to use either pull up or pull down resistor to that particular pin. Let's say here in this case we are using pin number 8. So at pin number 8, when it connects to the switch, I have used a pull down resistor, so that by default when this button or the switch is not pressed, when it's unpressed, then we will find a logic low, that means a ground, to this pin number 8. So when we press the switch, then only this circuit completes. Okay, and then this circuit closes and you will see logic high on the pin number 8, right? So when you press the switch, then it will the current flow through the circuit and you can find logic high on pin number 8. And when you release the switch, in that situation you will have logic 0, that means ground, on pin number 8. So this is how we're going to detect the state of the pin number 8 through the switch, and so that we can able to control this LED. So I hope now you are comfortable with the circuit. Just try to connect on a breadboard, and then we're going to move on to the screen and we're going to write a code and we're going to control this LED using a switch. So what you can see on my screen is I have a basic structure of the code where I have a setup function and I have a loop function. So this is very basic structure where we're going to start writing a code. So we need to have a two variable. One is for LED and one is for switch. So let's make a first integer variable. LED is equal to 13 because our LED would going to connect to pin number 13. We need another integer variable that will be, give it the name like a pin, and that will connect to pin number 8. So we'll give it a pin is equal to 8. Apart from this, we have to come back to the setup function and we have to define the pin mode for this, both of this pin number 13 and pin number 8. So I would going to write pin mode, and I want to set up the pin mode for pin number 13 where LED is connected. So I would say LED and then output, because LED is an output device. So we would have to configure this LED into the output mode. Then we have to take another pin mode, and then we have to define the mode of the pin, that is pin number 8, that is that will be referred as a pin, and this pin will be connected to switch, right? So pin number 8 is connected to switch, and switch is an input device. So we have to configure the mode for the pin variable to become an input. Then we go back to the loop function where all the magic happens, and we'll have to make one more variable, integer. I would give it the name read value, okay, is equal to, I would going to write digital read, because this digital read is an Arduino built-in function. This digital read in Arduino built-in function which reads the pin status, right? So let's say if I write here digital read pin, that means this pin holds pin number 8. This pin means pin number 8 where our switch is connected. So whenever we press the switch, then this digital read function will read this pin number 8 and it will store the status of the switch into read value. So once we have the status of the switch, we will say digital write. And what we want to do is basically when we press the switch, then we have to turn on the LED. So we'll say digital write, that is pin number 13 LED, comma, the value, that is a read value. So what is happening here is when we what is happening here is in this line of code, when we press the switch, then read value will hold a logic high, that means a 1. And when we say digital write LED comma read value, that means whenever we press the switch, logic is high and this LED will turn on, and whenever we release the switch, then read value will become in low and this LED will turn off. So let me upload the sketch and see if it can work. So let me upload it. And as you can see on the lower left corner, done uploading. So let me press the switch and see if it can work. So right now I'm pressing the switch. So whenever I press the switch, LED turn on, and as soon as I release the switch, LED turn off, right? As you can see on my screen. You may be thinking that this doesn't make much of the sense. When you press the switch, then LED turn on, and if you release the switch, then LED turn off. This means this program is not actually able to store the status of the switch. So what if we can make this program more intuitive? So whenever we press the switch, then LED turn on, and whenever we press the switch once again, then LED will turn off, right? So that will make more sense. So what I need to do is I have to remove this everything that is written into the loop function, and I would go back, and I need some more variable. So I need one integer variable called flag, and this flag will be 1 by default, and I need another variable integer that is a button state. So this will hold the status of the button. So by default our button state will be low. So what we're going to do here in the loop function, we have to take one more variable, and this variable is an integer variable. I would give it the name current state, and this will hold the current state of the switch. So I will say digital read, and the pin where we're going to connect the switch is pin number 8, so it will be referred it as a pin, as like previous example. So now we have to check something in a if statement. We have to write a if statement to check the condition. So if we have to check if current state is equals to high, that means whenever we press the switch, the logic is high, and we have to check the button state, this S will be capital, okay, is equals to low, because by default this button state holds the value 0, right? If this condition satisfy, which will only satisfy when you press the switch, then we have to check one more statement. We have to check the status of the flag. So if the flag variable is equals to, let's say if it's equals to 0, then we have to say digital write, and basically we have to say LED to become an high, and we have to make this flag to become an 1, and if it's not, then we have to say else. In the else statement again we have to say else, we have to make digital write, and we have to make this LED to become in low, so it will turn off the LED. I will explain you the logic, just give me a little bit of time. And then we have to make the flag variable to become an 0, right? When this is done, you can just select entire sketch and then do some auto formatting, so now it will look better. And then in the end we have to say button state is equal to current state, because we don't want any unusual behavior. So we just want to make sure whether the LED has been the switch has been pressed or not. So let me explain it to you what is happening here. So whenever we press the switch, this digital read reads the value of this pin. This pin means pin number 8, that is the switch, and it reads the status of the switch into this current state variable, right? So whenever we press the switch, this current state will become an high. So then it checks the if statement. So current state is equal to high, which is what it is happening when we press the switch, and by default the button state would become in low. So whenever we press the switch, this if statement executes and it passes this line of code, and it will go inside this another if loop, nested if loop, right? And it checks if the flag is equals to 0, means this line of code, if flag is equals to 0, which is not in this case, because by default, as you can see, we are making this flag variable to become in 1. So this would not going to execute, and this else part will execute when we press the switch first time. And then quickly this code runs out of this loop, and it come back again to the if statement again, and it checks flag is equals to 0. Now at this time, because we cannot even see it by the human eyes, the way this code executes so quickly. So when at first time this loop executed this if statements, when it went inside, when the control of the code went inside the if statement, this digital write become, means this LED become an low, and quickly it made this flag variable to become an 0. So when it loops through this if statement again, so it found out that flag is equals to 0, and it makes this LED to become an high. So when we press the switch, then quickly it turn on, turn off and turn on this LED, and when it turn on the LED, and then it make the flag is equal to 1, and then it go through this loop. So whenever we press the switch once again this line of code will be validated. I mean, the first if statement is validated and it go inside the if statement, and then at the second time it found out that the flag is equals to 1. So next time it will turn off the LED. Again it loop through the code, and next time it will find the flag become an 0, and then it will turn on the LED. Whenever you press the switch again, it will turn off. You press the switch, it will turn on. You press the switch, it will turn off the LED. So this is how you will, whenever you press the switch first time, your LED will be high, this LED would turn on. Whenever you press the switch again, then LED will turn off, right? So what is happening here is we are keep tracking this flag variable, right? So flag is nothing but the status of the switch. So whenever we press the switch first time, this LED will become an high, and it gives value 1 into the flag variable. Whenever we press it again, then it will make this LED to become in low and make the flag to become in 0. So it executes over and over again at every single press of the switch, and that is how we're going to control this LED using the switch. So let me upload the sketch and see if it can work, right? So let me press this upload button, and perhaps you can see in the lower left corner uploading, and it's done uploading. So let me press the switch and see if it works. So now I press the switch and the LED turns on. I press the switch again, LED turn off, on, off, on, off. So I hope you will find this video educational and entertaining. See you in the next video. Bye bye.